Understanding, a pragmatic framework motivated by large language models. Motivated by the rapid ascent of large language models (LLMs) and debates about the extent to which they possess human-level qualities, we propose a framework for testing whether any agent, be it a machine or a human, understands a subject matter. In Turing test fashion, the framework is based solely on the agent's performance, and specifically on how well it answers questions. Elements of the framework include circumscribing the set of questions, the scope of understanding, requiring general competence passing grade, avoiding ridiculous answers, but still allowing wrong and I don't know answers to some questions. Reaching certainty about these conditions requires exhaustive testing of the questions, which is impossible for non-trivial scopes, but we show how high confidence can be achieved via random sampling and the application of probabilistic confidence bounds. We also show that accompanying answers with explanations can improve the sample complexity required to achieve acceptable bounds, because an explanation of an answer implies the ability to answer many similar questions. According to our framework, current LLMs cannot be said to understand non-trivial domains, but as the framework provides a practical recipe for testing understanding, it thus also constitutes a tool for building AI agents that do understand. Kevin Leyton-Brown is a prominent computer scientist and professor at the University of British Columbia, widely recognized for his pioneering work at the intersection of artificial intelligence and microeconomics. He is best known for his contributions to algorithmic game theory, particularly in the design and operation of electronic markets, such as the multi-billion-dollar FCC incentive auction for radio spectrum and mobile agricultural markets in Uganda. Additionally, he is a leader in empirical algorithmics, having developed influential machine learning tools like S8scylla and AutoWEKA for the automated design and configuration of heuristic algorithms. A highly cited researcher and award-winning educator, he has co-authored foundational textbooks on multi-agent systems and co-taught a popular game theory course on Coursera to over 1 million students. Kevin Leyton-Brown was born on May 12, 1975, and grew up in Canada. He pursued his undergraduate studies at McMaster University, where he earned a Bachelor's of Science in Computer Science in 1998. He commuted and moved to the United States to attend Stanford University, obtaining his Master of Science in 2001 and his PhD in 2003 under the supervision of Yoav Shaham. His doctoral research focused on resource allocation in competitive multi-agent systems, a theme that would define much of his later career. After completing his education at Stanford, his desire to return to his home country led him to Vancouver in 2004, where he began his academic career as an assistant professor at the University of British Columbia. 1998 The role of cytochrome oxidase blobs in the development of ocular dominance and orientation maps. 1999 Taming the computational complexity of combinatorial auctions, optimal and approximate approaches. 2000 An algorithm for multi-unit combinatorial auctions. Bidding clubs, institutionalized collusion in auctions. Towards a universal test suite for combinatorial auction algorithms. 2001 Incentives for sharing in peer-to-peer networks. Smoothing out focused demand for network resources. 2002 Bidding clubs in first price auctions. Learning the empirical hardness of optimization problems, the case of combinatorial auctions. 2003 A portfolio approach to algorithm selection. Boosting as a metaphor for algorithm design. Incentive mechanisms for smoothing out a focused demand for network resources. Local effect games. Resource allocation in competitive multi-agent systems. SATSILA 0.9. 2004 Computing Nash equilibria of action graph games. Run the Gamut, a comprehensive approach to evaluating game theoretic algorithms. Understanding random SAT, beyond the clauses to variables ratio. 2005 Estimating bidders' valuation distributions in online auctions. 2006 A polynomial time algorithm for action graph games. A test suite for combinatorial auctions. Empirical hardness models for combinatorial auctions. Performance prediction and automated tuning of randomized and parametric algorithms. 2007 Bidding agents for online auctions with hidden bids. Computational analysis of perfect information position auctions. Computing pure Nash equilibria in symmetric action graph games. Hierarchical hardness models for SAT revenue monotonicity in combinatorial auctions. S8 07, the design and analysis of an algorithm portfolio for SAT SATSILA 2007, a new and improved algorithm portfolio for SAT. A tutorial on the proof of the existence of Nash equilibria. Valuation uncertainty and imperfect introspection in second price auctions. 2008 Essentials of Game Theory, a concise multidisciplinary introduction. S8 SILA, portfolio-based algorithm selection for SAT tractable computational methods for finding Nash equilibria of perfect information position auctions. 2009 An experimental investigation of model-based parameter optimization, SPO and beyond. Computational analysis of perfect information position auctions. Empirical hardness models, methodology and a case study on combinatorial auctions. Multi-agent systems, algorithmic, game theoretic, and logical foundations. Paramills, an automatic algorithm configuration framework. S8 SILA 2009, an automatic algorithm portfolio for SAT sequential model-based parameter optimization, an experimental investigation of automated and interactive approaches. Stepwise randomized combinatorial auctions achieve revenue monotonicity. Teams of selfish agents, an introduction to coalitional game theory. Time-bounded sequential parameter optimization. Trade-offs in the empirical evaluation of competing algorithm designs. 2010, Algorithmic Game Theory and Artificial Intelligence. Automated configuration of mixed integer programming solvers. Beyond Equilibrium, Predicting Human Behavior in Normal Form Games. Computing Pure Strategy Nash Equilibria in Compact Symmetric Games. Hydra, Automatically configuring algorithms for portfolio-based selection. Sequential model-based optimization for general algorithm configuration extended version. 2011 Action Graph Games. Economics and Computer Science of a Radio Spectrum Reallocation. Hydra MIP, Automated Algorithm Configuration and Selection for Mixed Integer Programming. Polynomial time computation of exact correlated equilibrium in compact games. Sequential model-based optimization for general algorithm configuration. Trusts, scheduling randomized patrols for fare inspection in transit systems. 2012 AutoWEKA, Automated Selection and Hyperparameter Optimization of Classification Algorithms. Behavioral Game Theoretic Models, a Bayesian framework for parameter analysis. Evaluating component solver contributions to portfolio-based algorithm selectors. Features for SAT parallel algorithm configuration. Predicting satisfiability at the phase transition. S8 SILA 2012, Improved Algorithm Selection based on cost-sensitive classification models. Temporal Action Graph Games, a new representation for dynamic games. The deployment to saturation ratio in security games. Trusts, scheduling randomized patrols for fare inspection in transit systems using game theory. 2013 An evaluation of sequential model-based optimization for expensive black box functions. AutoWEKA, Combined Selection and Hyperparameter Optimization of Classification Algorithms. Bayesian optimization with censored response data. Empirical analysis of plurality election equilibria. Identifying key algorithm parameters and instance features using forward selection. Revenue optimization in the generalized second price auction. Towards an empirical foundation for assessing Bayesian optimization of hyperparameters. Two-sided matching with partial information. 2014 A mobile market for agricultural trade in Uganda. ACLib, a benchmark library for algorithm configuration. Algorithm configuration in the cloud, a feasibility study. An efficient approach for assessing hyperparameter importance. Algorithm runtime prediction, methods and evaluation. ACLib, a benchmark library for algorithm selection. Empirically evaluating multi-agent reinforcement learning algorithms. Improved features for runtime prediction of domain-independent planners. Level 0 metamodels for predicting human behavior in games. Pragmatic algorithmic game theory. Leyton-Brown, Proceedings of the 15th ACM Conference on Economics and Computation. Understanding the empirical hardness of NP-complete problems. 2015 Efficient benchmarking of hyperparameter optimizers via surrogates. Polynomial time computation of exact correlated equilibrium in compact games. 2016 Artificial Intelligence and Life in 2030, the 100-year study on artificial intelligence. Counterfactual prediction with deep instrumental variables networks. Deep learning for predicting human strategic behavior. Efficient benchmarking of algorithm configurators via model-based surrogates. Multilinear games. SAT-Einstein, automatically building local search SAT solvers from components. Using the Shapley value to analyze algorithm portfolios. 2017 Auto WEKA 2.0, Automatic Model Selection and Hyperparameter Optimization in WEKA. Automatic construction of parallel portfolios via algorithm configuration. Deep 4, a flexible approach for counterfactual prediction. Deep optimization for spectrum repacking. Efficiency through procrastination, approximately optimal algorithm configuration with runtime guarantees. OASC 2017, Zilla submission. Predicting human behavior in unrepeated, simultaneous move games. Resource graph games, a compact representation for games with structured strategy spaces. The Configurable SAT Solver Challenge CSSC. The Positronic Economist, a computational system for analyzing economic mechanisms. 2018 Deep Models of Interactions Across Sets. Design and Evolution of an Electronic Agricultural Marketplace in Uganda. 2019 Incentivizing Evaluation with Peer Prediction and Limited Access to Ground Truth. Level 0 Models for Predicting Human Behavior in Games. Operations Research enables auction to repurpose television spectrum for next-generation wireless technologies. Procrastinating with confidence, near-optimal, anytime, adaptive algorithm configuration. Report-sensitive spot checking in peer grading systems. 2020 Dynamic weighted matching with heterogeneous arrival and departure rates. Exemplar guided active learning. Fiduciary bandits. Incentive auction design alternatives, a simulation study. PMI masking, principled masking of correlated spans. Predicting propositional satisfiability via end-to-end learning. A formal separation between strategic and non-strategic behavior. 2021 Automated configuration and selection of SAT solvers. Valid causal inference with some invalid instruments. 2022 MRKL systems, a modular, neurosymbolic architecture that combines large language models, external knowledge sources and discrete reasoning. Standing on the shoulders of giant frozen language models. The perils of learning before optimizing. The spotlight, a general method for discovering systematic errors in deep learning models. 2023 Formalizing preferences over runtime distributions. In context retrieval augmented language models. Parallel context windows for large language models. Utilitarian algorithm configuration. 2024 Generating benchmarks for factuality evaluation of language models. How to evaluate behavioral models. Incentive auction design alternatives, a simulation study published version. Matching papers and reviewers at large conferences. Pay to not play, monetizing impatience in mobile games. Rationality report cards, assessing the economic rationality of large language models. Steer, assessing the economic rationality of large language models. Understanding iterative combinatorial auction designs via multi-agent reinforcement learning. Understanding, a pragmatic framework motivated by large language models. K. Leyton-Brown, Y. Shaham, AR14 preprint AR14 2406.10937. Unsat solver synthesis via Monte Carlo forest search. What can natural language processing do for peer review 2025? How malicious AI swarms can threaten democracy. Steer Me, assessing the microeconomic reasoning of large language models. Strategic foundation models. Practical, utilitarian algorithm configuration. Not fully cited, 2025 Near-linear mirror algorithms for stochastically ordered priors. 2025 Elementary Net, a non-strategic neural network for predicting human behavior in normal form games. 2025 Efficient individually rational recommender system under stochastic order. 2025 Modular reasoning, knowledge, and language systems. 2024 Understanding, a pragmatic framework motivated by large language models. 2024 The new faculty highlights program at AAAI 21. 2022 Games with sequential actions, the perfect information extensive form. 2022 Generalizing the extensive form, imperfect information games. 2022 Games in normal form. 2022 Further solution concepts for normal form games. 2022 Uncertainty about payoffs, Bayesian games. 2022 Repeated and stochastic games. 2022 Analyzing games, from optimality to equilibrium. 2022 Economics and computation. 2022 Learning under invariable Bayesian safety. 2020 Auto-WEKA, automatic model selection and hyperparameter optimization in 2019 Auto-WEKA, automatic model selection and hyperparameter optimization in WEKA. 2019 Mechanism design and auction Superscript 1. 2016 ACM Conference on Electronic Commerce 08 and 09 Introduction. 2014 Two-sided matching with partial information. 2012 Trusts, scheduling randomized patrols for fair inspection in transit systems. 2012 Algorithmic Game Theory, Special Issue Introduction. 2010 Special Issue Introduction, Algorithmic Game Theory. 2010 Comparing Position Auctions Computationally. 2010 A Tutorial on Rational Generating Functions. 2010 SAT-Stein, Automatically Building Local Search SAT Solvers from Components. International Joint Conference on Artificial Intelligence IJK, 517-524. 2009 Symmetric Games with Piecewise Linear Utilities. 2009 Book Announcements, Multi-Agent Systems and Essentials of Game Theory. 2008 Empirically Testing Decision-Making in TAC SCM. 2007 Valuation Uncertainty and Imperfect Introspection in Second Price Auctions. 200,718.1 Past Work on Testing CA Algorithms. 2006 Performance Prediction and Automated Tuning of Randomized and Parametric Algorithms, an Initial Investigation. 2006 Conference Report, the 4th ACM Conference on Electronic Commerce. 2003 Collusion in Unrepeated, First Price Auctions with an Uncertain Number of Participants. 2002 Steer Me, Evaluating LLMs in Information Economics. Empirical Aspects of Plurality Election Equilibria. Foundation Models for Boolean Logic. A retrospective on the CP 2006 paper Performance Prediction and Automated Tuning of Randomized and Parametric Algorithms. Understanding the empirical hardness of NP-complete problems using machine learning to predict algorithm runtime. 4.4 Portfolio-based methods for algorithm selection. Unlocking the power of modern ML for use in CSP. Deep learning for predicting human strategic behavior. Supplementary material. Finding the smallest tree in the forest, Monte Carlo forest search for unsat solving. Empirical aspects of plurality elections equilibria. Station repacking in the incentive auction. Identifying valid instruments via effect agreement. Beyond equilibrium, predicting human behavior in normal form games. Improving Maple LCMDIST chrono-BT via variable reindexing invariance. Allocation for social good. Computational analysis of perfect information position auctions. Understanding random SAT action graph games, and an algorithm for computing their equilibria. Bidding agents for online auctions with hidden bids. Equilibrium computation, theory and practice. Revenue optimization in the generalized second price auction. Response to Professor Milgram and Professor Ozubal's comments on the second Y River Package Bidding Conference. Incentive auctions and spectrum repacking. Student attitudes towards partially automated peer grading in mechanical Ta. Bayes-Nash equilibria of position auctions. Local effect games, and an algorithm for computing their equilibria. Understanding game theoretic algorithms, the game matters.